shows that lines intersect and finds the coordinates of P, the point of intersection. To find the point of intersection, it will be useful to rewrite given equations in parametric form, or it's actually the same as a vector form. So we equate just it to some parameter, let it be lambda here and mu here, and solve for x, y, z in terms of lambda. So we can see that x is 2 plus lambda, y is 2 plus 3 lambda, z is 3 plus lambda, and in vector form it becomes 2, 2, 3 plus lambda 1, 3, 1, 2, 2, 3. It's position vector of a point on the line, and 1, 3, 1 it's a direction vector of this line. And to find the point of intersection, it's not needed to write a vector form. It's enough to consider just the parametric form. And for the second line, equations become x is 2 plus mu, y is 3 plus 4 mu, and z is 4 plus 2 mu. And since a point of intersection is a common point, we consider a system of equations. So 2 plus lambda is 2 plus mu, 2 plus 3 lambda is 3 plus 4 mu, and 3 plus lambda is 4 plus 2 mu. And we can see that there are two unknown variables and three equations, so we choose any two equations, for example the first and the second, and solve for lambda and mu. And from the first we can see that lambda is mu, and the second becomes 2 plus 3 lambda is 3 plus 4 lambda, hence lambda is -1 and mu is also -1. Mu is -1 and lambda is also -1. Hence we need check the third equation. It becomes 3 plus -1, and the right hand side 4 minus 2. 2 is equal to 2. It's true, hence there is a point of intersection, and we just substitute lambda or mu into equation of any line. It doesn't matter. So for example, from this we can get that the required point is 2 minus 1, 1, 2 minus 3, -1, and 3 minus 1, 2. So it's the required coordinates of point P. And notice that if you need to show that two lines are skew. Skew means two lines are not parallel and do not intersect. Parallel or not, we can conclude from comparing direction vectors. If one direction vector is some constant multiplied by another direction vector, hence they are parallel. And if it's not true, hence they are not parallel. And then you try to find the point of intersection, and you do the same, solve the first two or any two equations and check the third. And if you get that the third is not true, hence it means the next, that if two lines are not parallel and don't intersect, hence they are skew. Here it's not necessary to check if they are parallel, because if they are parallel, we would get infinitely many solutions. But it's clear that these lines are not parallel here. And the next, find the Cartesian equation of the plane pi that contains these two lines. So to find the Cartesian equation, we use the next equation. It is given in a data booklet. R minus a dot product normal is equal to 0. A, it's a position vector of any point on the plane, and we can use this point P. So a vector is 1, -1, 2, And what is normal? Normal can be found as cross product of two direction vectors, because since two lines lie in a plane, we know that cross product is a vector which is perpendicular to the plane in which these two vectors lie. So it's just dot product, and you can use directly a formula from a data booklet. I use another formula. It's determinant of the next matrix ijk, and the first direction vector it's 1 3 1 1 3 1, and the second direction vector is 2 3 4 plus mu 1 4 2 1 4 2 1 4 2, and it's I, always plus I, and determinant of this 2 by 2 matrix, determinant of 2 by 2 matrix, it's this product minus this product, so it's 6 minus 4 2 minus j, always minus j, and determinant of this 2 by 2 matrix, it's 2 minus 1, negative 1, plus k, y negative 1, it's 2 minus 1, it's plus 1, and plus k, determinant of this matrix, 2 by 2 matrix, it's 4 minus 3, it's 1. And for normal, it's important only direction, so we can take any multiple of this vector. And as normal, we can consider, for example, 2 negative 1 1. 2 negative 1 1. Hence, this equation becomes x minus 1 multiplied by 2 plus y minus 1 multiplied by negative 1. We just use formula for dot product. It's x by x plus y by y plus z by z, and I, it's a vector with coordinates x, y, z, and plus for z it becomes z minus 2. I hope it's clear for you. Multiplied by 1 is 0. Open parentheses and simplify, so it becomes 2x minus 2 minus y minus 1 plus z minus 2 is 0. 2x minus y plus z is 5. It's the required Cartesian equation. And the next, let's delete it, and the next question, the point Q lies on pi. So let's rewrite, it becomes 2x minus y plus z is 5. And the line L passes through the midpoint of PQ. Point S is on L, such that PS is QS is 3, and the triangle PQS is normal to the plane pi. It means perpendicular, given that there are two possible positions for S, find their coordinates. So it looks like this plane, and there are 2 points PQ with coordinates 1, negative 1, 2, Q 3, 4, 3, and line through midpoint. Definitely we need coordinates, so midpoint becomes 2, 3 over 2, and 5 over 2, and somewhere there is S, so that this distance is 3, and this distance is also 3, and you can guess that S also can be here. So it's S1, S2, and since triangle PSQ is normal, it means that this line through M and S is perpendicular to the plane, and hence the direction vector of this line is equal to the normal of the plane. And definitely we will need the equation of this line, so let's find the vector equation of this line. And we need a point, so it's 2, 3 over 2, 5 over 2 plus some parameter, let it be t, and direction vector, which is equal to the normal, and normal it's just coefficients in front of x, y, z. It's 2, negative 1, 1. 2, negative 1, 1. And any point on the line has coordinates 2 plus 2t, 3 over 2 minus t, 5 over 2 plus t. And if we make some equation, we can solve for t and find the required coordinates. But how to make an equation? The first idea is to consider 2 points PS and also Skew, and using a formula for the distance between 2 points, square root of x2 minus x1 squared plus y2 minus y1 squared, and so on, and hence to get equation with respect to t. And if you do that, you get finally 0 is equal to 0, and you can find nothing and just waste time. So we need any other idea. Any other idea may be the next. In general, we can see that it's an isosceles triangle, and also since direction vector of L is perpendicular to the plane, it will be perpendicular to any vector in the plane. So we can try or we can set vector ms and consider vector pm, and hence they are perpendicular. We can try consider dot product, and we also get nothing. But also we can consider PMS, this triangle, and since distance PS is 3, and we can see that we can calculate distance PM, and we can set distance SM and connect them using Pythagoras theorem. And let's try do that. So PM distance, using formula for the distance between 2 points, it becomes 2 minus 1, 1 squared, plus 3 over 2 minus 1, it's plus 1, it's plus 2 over 2, so it's 2 over 5 over 2 squared, plus 5 over 2, which is 2.5 minus 2, it's half squared, and it becomes 1, which is 4 over 4 plus 25 over 4 plus 1 over 4, and it's 30 over 4 or root 30 over 2. And coordinates of S are this, and the coordinates of point M are these. Hence coordinates, or let's consider SM vector, and it becomes 2 plus 2t minus 2, 3 over 2 minus t, minus 3 over 2, and 5 over 2 plus t minus 5 over 2, which is 2t minus t plus t, and hence the required distance, is just the magnitude of this vector, becomes 2t squared plus t squared plus t squared. 4 plus 2 is 6 t squared, or root 6 t. Hence for the triangle PMS it becomes 3 squared 9 is equal to the sum of squares. It's PM squared plus SM squared is equal to 30 over 4 plus 6t squared. It's quadratic, so 9 is 36 over 4 minus 30 over 4 is 6t squared, and 6 over 4 is 6t squared, hence t is plus minus a half. Hence the required coordinates become, we just substitute, for t is plus a half, the first possible point S1 has the next coordinates 2 plus a half multiplied by 2, it's 1, so it's 3 over 2 minus a half, it's minus 2 over 2 minus 1, and 5 over 2 plus a half, it's 3 negative ones, it's plus 1, 3 over 2 minus a half, it's plus 1, 3, 1, 3. And the second possible point for t is negative a half, the second possible point becomes 2 minus 1, 1, 3 over 2 plus a half, it's 2, and 5 over 2 minus a half, it's 4 over 2, it's 2. So these are required points. And that's all for this question.